Hey, Zach.
Hey, Zach. How are you?
Good. How are you doing?
Good. How are you doing? Pretty good.
Let's see here. No, that's not the screen I want to share. That's my other class. How do I get out of that? Oh, here we go. Okay. Cool. All right.
How's your weekend?
I think I'm going to give you the same answer I gave you last week, which was it was really busy. I can't recall if I mentioned this before, but there's a conference that I've been invited to in the middle of February, which is nice. But what it means is I have to write a paper because I'm supposed to present at the conference, right? So this is a philosophy conference at the school that I went to for college at New Mexico State University. And what they're doing is they're inviting back some of their students, undergraduate students who have gone on to have careers in teaching and philosophy. And so I'm one of those, and so I've been spending my weekends, all spare time that I have, writing this paper.
What's the paper on?
Well, it's on theories of consciousness. So this is a topic that we won't get into, unfortunately, in this on philosophy of mind. But there's this division amongst philosophers who think about consciousness, about whether you should offer what's called a first-order theory of consciousness versus a higher-order theory of consciousness. And basically the distinction is this. The higher-order theory says that a mental state is conscious just in case you are conscious of having it. You're conscious of it. The ones that aren't conscious are the ones you're not conscious of, not conscious of having. Okay? That sounds like a familiar thing that you might say if you were asked, well, how do you distinguish conscious states from unconscious states? Well, I'm conscious of having the conscious ones. A first-order theory, though, denies this. The first-order theory is basically the view a state is conscious if it makes you conscious of something else. Right? So the reason that my visual experiences are conscious is that they make me conscious of you. And your auditory experiences are conscious because they make you conscious of my or whatever. Whereas unconscious states are those that don't make you conscious of something else. So, two different options there. In this paper, I develop an objection to higher order theories. So, hey guys.
Hello, sorry. We're having a rough day here, like snow and...
Oh, okay.
Yeah.
Well, it's good that there's an explanation. Now, what happened to... Let's see, Zach, I don't know why your video went away just then. Hold on a second.
We still have it.
You still have it? Good. Okay. I don't know why I don't still have it. It's supposed to be constant presence. Grr. Let's see if I can get that back. Here we go. Okay, good. Now I have you both back. Now I can see you both.
But there's reverb.
There's reverb?
Oh, not anymore.
Not feedback?
Anymore. It just went away.
Okay, good. All right. So, anyway, Zach asked me how my weekend was. I said I was busy working on his paper. He asked what my paper was about, so I was just giving him a quick rundown of the topic. And, one of my projects in my philosophical career has been arguing against these higher order theories of consciousness. So, anyway, okay, guys. Well, since we have a critical mass here, do you guys happen to know if Sam will be here?
I thought I saw him at school today.
It's not your job to keep track of him, so don't worry about it. All right, so let's start with some reminders and an announcement. The reminders are that you should start thinking about your possible research topic project. You really should look at the schedule ahead, and to do that, go ahead and look at the document that's on eCollege that's just called, I think it's just called Schedule. It's up in the link to it is in the upper left-hand part of the page under Course Home. Look at the topics that we're going to be talking about, see if anything it seems interesting to you, or think back over what we did the first semester and what we're doing now. And if something has been of particular interest to you, that's a good place to start. Now, you can, of course, send me thoughts in an email, like, oh, I was kind of interested in this. What do you have a suggestion for what a topic on this might be? I'm happy to help you work out a topic a little bit between now and whenever it is that the official due date for the proposal. I forget what it is off the top of my head, but I think it's somewhere in February, kind of later in February. So just start thinking about that. Have it on your mind that you got to come up with a topic, and just kind of let it sit there for a while. You don't have to have it now, but it's good to start thinking. Also, remember that you guys have an in-class presentation this semester, just like you did last semester. You guys kind of back-loaded those last semester, so they were all right near the end of the semester. This time, maybe we could have it a little more spread out. We don't have to, but start thinking about what you might want to present on. Again, that means looking at the schedule, the semester schedule, and thinking about what topics you might want to present. So, but the format of the in-class presentation is exactly like last time. You guys all did a great job with that, so just do that again. So actually, Jacob and Alexandra, assuming it's just going to be you two at this point, could you zoom in just a little bit? There's a lot of, especially to the side of Alexandra, there's just a lot of room there. Yeah. That's good. That's better. Thanks. Okay, and the other thing, so those are reminders, and then the other thing is the announcement is writing assignment 4. It's going to be on philosophy of mind. I'm going to ask you to, evaluate one of the arguments for one of the positions that we've looked at, or defend materialism or dualism about the mind, something like that. I'll give you a number of topics, and I'll post that on eCollege pretty soon. My hope is that I'll post it later today, okay? So you can go to eCollege, have a look at the topics. And maybe that way you can kind of be thinking about those topics as we have our discussions in class. That might help you start formulating your ideas for the paper. Okay? Any questions about that stuff? All right. Well, then let's move on to our topic for today, which is just a discussion. There's no new material for today. I just wanted to talk about the question of minds and computers, and to the extent to which we should think that the mind is a computer. If you need a refresher here, just remember a computer is a systematic symbol shuffler, something that takes symbolic inputs and follows rules to transform those symbolic inputs into symbolic outputs. The set of rules is called a program. And so the computer model of the mind is just that there are a lot of ways to spell this out, actually, but here's a kind of basic one. Mental states, right, your thoughts, your experiences, are symbols of a kind. Philosophers like to say representations. They're representations. Thoughts, experiences, pains, emotions, these are these are representations, a kind of symbol in the mind. Right, a symbol stands for something else, represents something else. Mental processes like thinking or forming a memory, retrieving a memory, these are systematic transformations of the symbols, retrieving symbols, converting those symbols into new strings of symbols, and so forth. That's how to think of the mind like a computer. So this is a slide from last time, really. Right, the idea is that the mind is the program, the software that's being run by the hardware, which is the brain. Now, it's funny to think of the brain as having symbolic inputs and outputs, but just remember this idea that sequences of nerve impulses might be treated like almost like sequences of ones and zeros, right? You can almost imagine the output of a neuron being like almost like Morse code, right? In fact, if you listen to them, they kind of sound like Morse code. You use a device that lets you, as it were, listen to the firing of neurons. So you can think of the eye and the skin and the ears as converting physical energy into sequences of ones and zeros or whatever with the nervous impulses. And then your muscle effectors, the nerves that go from the brain to the muscles, are sending the muscles strings of, or they're converting strings of symbols into muscle movements or whatever. Okay. Yeah. So with that, we've got these two arguments. Pretty interesting in their own right? We got Turing. Alan Turing's an important figure in the history of computers and the history of thought in general. He played an important role in cracking German codes during World War II, and he sort of laid the foundations, the conceptual foundations for all of modern computer science. In fact, his description of a machine that computes really is the way in which we still explain what it is to compute a function. To compute a function just is to do something that could be performed by one of these machines that Turing described, right? The thing with the tape and the ones and the zeros and moving along the tape and all that. And of course, as you guys read, he has this proposal for how to test for intelligence in machines, now called the Turing test. Here's a little depiction, a couple depictions of what the Turing test is. Sorry, that one, it's funny, the typeface on the one on the bottom does not come through very well. But anyway, I think you guys in your journal entries convinced me that you understand the Turing test. And by the way, I read the article that Zach shared. That was pretty interesting, I thought. Did you guys? Alexandra did. Good.
Yeah.
So let's talk about the Turing test a little bit. Whatever you want to say about it, fair game here. The two kinds of questions that are typically asked is, and if you want to try to approach this independent of Searle's argument, right? So Turing has this proposal for what it is to be an intelligent machine. Searle has an argument that can be used against that claim. But even without knowing about Searle's argument, you can ask two questions about the Turing test. First, is it necessary for intelligence that something pass the Turing test? That is, if something is intelligent, must it be able to pass the Turing test? That's a necessity claim. On the other hand, you can ask, is it sufficient for intelligence that something passes the Turing test? That is, if something passes the Turing test, then it's intelligent. Those are the two kinds of questions you can ask. But anyway, yeah, Alexandra, you want to get us started here?
Yeah. I guess an interesting thing I kind of noticed from the article was that it seems that, I think the author mentioned it, was that the Turing test really measures not really like human intelligence of the robot or computer, or more like if it can like mimic like kind of conformed answers, or like what general human thinking process is like, and that's kind of different from actually like understanding the essence of the conversation. And I think that the computer passed that kind of simulating human thinking because it sort of like appealed to whatever doubts that the human had if they couldn't understand it, because like the kid was foreign or because he was like young. So I think it's a good attempt, but I think it isn't good at answering things like sarcasm or like colloquialisms, and it isn't able to like reason when things aren't like perfectly like formulated for them. But like an actual human can like infer, and the computer can.
Right. So Alexander, the sort of the punchline though is that you accept the claim that this computer's having passed the test isn't sufficient for its being intelligent, right? That's your view. Yeah.
Yeah.
Yeah. Go ahead, Jacob. And
I agree with Alexandra. Before reading the article, I thought, okay, this test could make sense. But then after reading through the example, it doesn't really appear that. Well, first I'll backtrack. Even though the computer program fooled the judge, it doesn't really mean that the program is intelligent. And this goes. I think it goes back to the definition of intelligence, which I don't actually know too much about, but reading from the computer, like about what the computer is saying, it just doesn't appear that the computer is intelligent. And also, going back to Cyril, of course I didn't come up with this, but with his Chinese room, with the translator and the computer understands nothing. But then the question can be asked: do humans truly understand anything? Either are we just repeating what we know, or what goes the input output? You go. I said a lot there, but
yeah, you did say a lot there. That was an interesting thought there at the end about does Searle's argument maybe lead you to wonder if you understand things? Yeah. So a couple things. I'm not going to try to say too much here. Then I'll go to you, Zach. Your question, Jacob, about the definition of intelligence is going to be an important one. And it's not always clear that everyone who talks about these examples is concerned with the same thing. So, for instance, some people will say, okay, well, I'm willing to let this be a test for intelligence, but not understanding. And if you read Searle's article, he seems more concerned with the notion of understanding than intelligence. But, these terms are a little bit slippery. Searle has a thing he says about that maybe we'll get to, but okay. So, but so far, certainly the Turing test isn't looking very persuasive as a sure sign of intelligence. Yeah, right. That's fair. Yeah. Go ahead, Zach.
So I agree that it's not necessarily the best test for intelligence or consciousness, which I think is actually somewhat maybe the more important question, which Alan Turing seems to not be interested at all, which I think is interesting. whereas Cyril does point out that this doesn't prove anything for consciousness. One thing that I think would provide the possibility for a computer to understand consciousness is that in the Chinese room, you're not consciously doing anything with Chinese, you're just following the instruction book. But if this person were learning Chinese, then that would be indicative of intelligence or consciousness or actually thinking processes. So my question is, if we could teach some computer device to take in new data, incorporate it, and then make connections between it so it was learning in the same way that a small child learns, would that be thinking? And I think it would be thinking. And I'd also like to say that, though I don't agree that passing the Turing test is the only marker or a definite marker for intelligence among computers, I also think it'd be important to note that failing the Turing test is also not the best marker for being unintelligent, because we might be able to devise a machine that is actually maybe even conscious, or that it's thinking and understanding, but it's not thinking and understanding in the same way that humans do, so it can't mimic human personality.
I agree with that.
Yeah, that's an interesting point. It's a good point. And it's a point that some other authors have made, is that, look, surely failing the Turing test doesn't imply that you're not intelligent. Because I'm just going to develop your point a little bit, Zach. People have pointed out, look, what if there was a super intelligent machine that was so smart that it could figure out things so much faster than any human possibly could? You sit there, you type a really complicated like math problem or something into the terminal there. You're taking the test, and boom, a correct answer comes back right away. You go, oh, well, this can't be a human. Surely that's a funny reason to say that the thing that answered your question is not intelligent, right? Yeah. So. Yeah, the Turing test, if you take it as both necessary and sufficient for intelligence, seems to rule out superintelligence or intelligence of other kinds, like the kind of animal. An animal can't participate in the Turing test. So, yeah, go ahead, Jacob.
The other thing that I thought was just kind of weird was that the computer program is written by a human, and the only reason that the computer can understand or can respond is because of what the human tells the computer to respond to, like the certain words, respond with this answer so that you can trick them. So I almost got the impression like it was more like it was just the human talking to the human, but through a computer.
Interesting. Yeah, I see what you mean by that. Yeah, Zach, do you want to comment on that?
I was just curious, has IBM's Watson ever taken the Turing test?
Oh, that's an interesting question.
I don't know.
I feel like I would have heard that it did. I'm not sure why you couldn't.
Mm-hmm. Because technically, one of the problems with computers convincing other people that they're human is that a computer is in a tiny little metal box. It doesn't have much opportunity for experience or for going out into the world and learning and interacting and stuff, which is important for developing personality. So what if we made a computer that learned along the same vein as Watson, and we just let it roam free with the internet for like a decade? What if we came back to it and saw how it progressed, and maybe at that point it would have started to develop maybe a rudimentary personality?
Yeah, so that's a very interesting suggestion. Okay, but let's go back. So we need to think about what the computer is doing when it does these things. So Zach, you've said, okay, look, I'm willing to say that a computer with a very simple program that's designed to allow it to respond to specific sorts of questions, that might not be intelligent, that might not have understanding. But what if we let it do these other things, right? What if we let it learn? What if we you have several examples, and some of them were in your journal entry about teaching it using images, or now you've suggested maybe it could roam about the world. remember that the computer model of the mind is a general view about the mind. So everything that happens in the mind has got to be a matter of symbolic inputs transformed via rules into symbolic outputs. Now, maybe we want to allow that computers are able to, I don't know, store new sequences of inputs. And this is a way in which they might be acquiring new information in some sense, right? So you give it visual processors, or you give it cameras or something as eyes, and it's able to receive an image of a new object, and it codes that new object that it's never seen before with a new pattern of zeros and ones. Okay. So this is very similar to a reply that is sometimes made to Searle, which is that, look, sure, I grant that, this Chinese speaking computer that you are in effect the processor for, right? In a way, Searle is just standing in for whatever it is in the computer that transforms the symbols according to rules, right? I'm willing to grant that thing it doesn't understand, maybe even isn't intelligent. But what if we put this thing in a robot that had, a vocal apparatus that produced noises and that it was able to go about and experience the world? Searle has a couple of replies for this. First, either you're saying that this process of having experiences or learning or being taught something are not things that are themselves simply a matter of running a computer program. But if that's your view, then you're really granting Searle's argument. You're really granting that he has shown that nothing understands purely in virtue of running a computer program. Strictly speaking, that's all Searle was arguing. Strictly speaking, all he was trying to show is that nothing understands merely in virtue of being a symbol shuffler, a systematic symbol shuffler. That's what he takes his argument to show. Okay. So if you think, well, you could have a computer in a machine that understands if that machine could do other things. Searle says, strictly speaking, I'm not opposed to that view. Okay. So, but the more interesting reply goes as follows. All right, look, if you're really an advocate of the computer model, then when you talk about a computer learning, that has to be a matter of its receiving, symbols, zeros and ones, and transforming those according to rules. All right, very well. Put me in a giant robot, and I will give me all the rules that I need, and I'll take the new inputs that come from the, camera eyes, and I'll transform those zeros and ones into new zeros and ones that will make the robot move around. That might, when sent to the vocal apparatus, make the robot say something. Let me do all that stuff. There still doesn't seem to be any more understanding than there was in the case of the Chinese room. Yeah, go ahead, Zach.
I think that there's more to learning, even if you have a computer system idea of the brain, than just memorizing a fact, putting it in zeros and ones, interpreting it as data, and then storing that data, what have you. Because I think that when you learn that way, that's the least effective way to learn, and I feel like there have been different educational scientists that have proven that. Part of learning is also making connections and stimulating yourself emotionally or psychologically in a way that must be included in this sort of computer program. And if we had a sufficiently complicated program that did that, I think it would be difficult to not consider that thought, even if it's still a computer program.
Okay, so you've used terms like making connections, but we've got to think about what that might be. What might it be to make a connection, or acquire associations for a computer? And if once you have an answer to that, Searle's going to say, okay, let me do that. He still doesn't think there's going to be any more reason to say that there's understanding there than in the Chinese room. Right? Because ultimately, drawing an association is going to have to be spelled out in terms of relationships among symbols. And in a way, what Searle's basic point is that those symbols are just physical, like the uninterpreted shapes on those cards that he gets in the Chinese room. And that for the computer, that physical shape, so to speak, or sequence of zeros and ones will never have any meaning. It's a tough argument. It's an interesting argument. He's very famous for this argument, by the way.
I don't know what to say.
Now, Jacob, I heard you say you're not sure what to say. Is that because you're finding the argument convincing now? Because I know in your journal you're like, I can't go with Searle here. I think.
But no. In my argument, I say I could see both sides. I think that's what I said. It's like I don't like committing to one or the other because they both make convincing arguments. But now I'm starting to see more of Searle's argument.
Yeah.
The question.
Go ahead.
Okay, so our problem is that when a computer or a robot with this possible conscious programming sees a washing machine, it isn't actually seeing the washing machine, it's seeing a bunch of coding that is designed to resemble a washing machine in its processes, which it then connects to words or which it then interprets as a symbol. But aren't we, and I believe Sam has made a similar argument to this in the past, that when we see a washing machine ourselves, I'm using an example of a washing machine, we aren't interpreting the actual washing machine, we are interpreting the symbolic observation of the washing machine in our eyes. So the robot might process code for the image of a washing machine, connect that to a washing machine and the definition of a washing machine, and it would still understand what this code means by definition of a washing machine washes clothes in the same way that when we see a washing machine, we understand the definition as this washing machine washes clothes. And then if Cyril might say that, okay, so then you just make a connection and say, if you get this, it says it washes clothes, but that's just a response. It's a pre-programmed response. Then if you explain to it what washing clothes means, so it understands that it's taking the bacteria out of everything or taking the dirt off, then it would know what washing clothes is. And then I guess Cyril could even take it even further in an absurd way of saying, well, it doesn't understand what dirt is, but you have just keep teaching it forever, and you teach it everything eventually, in the same way that when a young child sees a washing machine for the first time and it's explained what the washing machine does, it doesn't know necessarily what clothes are or where dirt is, so you just keep explaining and explaining and explaining.
Right. But so the problem is here that you're using psychological vocabulary to describe what the computer is doing. And that can make it seem like it's got to be, that can make it seem plausible to suppose that it must actually be learning. It must actually be having these psychological states. But what Searle is going to do, he's going to come back and say, look, you've got to be clear about what the computer model says learning about dirt is. And what it will be is, so you say the word dirt, right, in the presence of some brown, not very well formed stuff, right? And so you got the sound and the vision, but sound and light, let's say. But for the computer, what those things are strings of zeros and ones. And it may be that the computer is designed so that, so to speak, there's a certain storage area where sounds and sound and light that gets presented to it together get put together in the same kind of storage area, so that in the future, if one string of zeros and ones gets accessed, the other one is likely to get accessed as well. That's what association is. Okay, so to say that it knows what dirt means is something like, well, when it then in the future hears the word dirt, which is the occurrence of a certain string of zeros and ones, because its auditory device will simply convert mechanical energy into strings of zeros and ones, that will, make it likely that it will access that other string of zeros and ones that it acquired when it was presented with brown, misshapen stuff. In a way, what Searle's point is that, look, all the understanding just goes away here when we start talking about zeros and ones and the propensity to access certain zeros and ones and the propensity to transform certain strings of zeros and ones into other strings of zeros and ones, which when sent to like the vocal apparatus cause it to say, that's dirt or something like that. Did that make sense? I'm trying to present Searle's argument in as convincing a way as I can, but
it did make sense. My question is, does the problem change at all if you include not just the sound, not just the light, but also a digital written definition that the computer also stores, so that, because when you think about how humans associate things, we associate normally sound, image, which is light, and then the definition, which is something we've learned over time. And I guess in the computer sense, it might not necessarily be learning, but would be input through the keyboard, which might function similar to learning. But then, Jacob, you go.
Okay, this might be a really big of a stretch, but have you ever seen the movie WALL-E?
Yeah.
And that has two robots or computers that have compassion for each other, but they weren't programmed to have that compassion. So what would Cyril say about that? They learned, they did that on by themselves.
Yeah, so this is a little bit along the lines of a question Alexandra asked about, well, what if a robot had emotions? Would that, in fact, I think your question was, are emotions necessary for intelligence, which is an interesting question. I think traditional computer scientists would have said no, but my sense is that there's starting to be a little bit of a change in cognitive scientists' attitude about that they're starting to think emotion might be more important to intelligence than previously suspected. But anyway, I'm trying to decide if I should go to you now or continue my response
No,
to
it's okay.
Jacob.
No, go for it. No, it's fine. I'm good.
So, right. What would Searle say? So in Searle's name, think of the word surly, a surly personality. It's Searle, the first part of that.
Yeah.
That anyway.
Okay.
What would he say about Wall-E and these critters, these robots? Well, he might say that sure, those things might be possible, but either they're only exhibiting behavior that looks like compassion, for instance, or they're not doing what they're doing simply on the basis of running computer program. There's something else about them that allows them to feel compassion.
What would he say if people said that it was like learned behavior, since affection a lot of the times is like, would he say it's just learned behavior, but they're not actually like knowing what they're doing?
You mean humans?
The robots, like they show compassion, but would he argue that their compassion is learned behavior, but not that they have like a conscious understanding of the compassion itself?
Well, it depends on what the account is of how they do what they do. It could be. So if your account of what they're doing is just a matter of zeros and ones being transformed according to rules, then Searle is going to say, well, it's a kind of illusion. You could call it a learned behavior if you want, because it might be something that they acquire over time in response to new inputs.
Like
but
the input.
It isn't genuine understanding of what's happening because there's no conscious experience. I mean, I think Searle thinks that conscious experience is necessary for real understanding. So it depends. But, that might not be your account of what's happening with those Wall-E robots. You might think that there's something going on in them that is not just a matter of running a computer program, in which case he might say, fine. Look, Searle thinks that if you built a mechanical brain, that is a mechanical object that had the same causal powers as the brain, that it would probably be a mind. But he doesn't think that things have the same causal powers as a brain, merely in virtue of transforming symbols according to rules. I understand the problem some of you guys are having, because you're starting to think, well, what is it that the brain is doing that the computer's not doing?
Yeah.
Right? I know why this bothers you. But we're starting on the path right now to the revival of dualism in contemporary philosophy of mind. It's these kinds of thought experiments that have fueled a kind of re-emergence of dualism. We'll get back to this. Yeah, go ahead, Jacob.
Is Searle a dualist?
No. He says he's not a dualist.
Then what?
He says that brains cause minds, and that it's a completely biological phenomenon, just like circulation and digestion.
But then can a computer? So and then does he also say that a computer brain? So if you remake the brain into a computer, can that create a mind?
His answer to that is not just in virtue of running a program.
What does he mean by that?
He means something more must be going on than whatever he could do in a room by transforming uninterpreted symbols according to rules.
So then isn't that almost going to dualism, that you need something else that your brain can't?
Yeah, I have to admit, this is where Searle gets a little tough for me, because I understand his argument against the computer model, I think, pretty well. In fact, I think it's a pretty good argument. Although I'll tell you how some people have responded in just a moment. But then his positive account of what it is about a brain that's important to having a mind is it's kind of hard to understand, because he talks about the causal powers of the brain, but it's a little difficult to understand concretely what the causal powers of the brain are. Is it, the brain has the causal power of creating an electromagnetic field? That's not what Searle is talking about. It's something about the way states of the brain, neural impulses, cause other neural impulses directly. It's a little hard to get, which is why some people think that Searle is really a dualist. He just doesn't want to say he is. Yeah, go ahead, Zach.
Okay, so we know that computers can make associations. And we know that humans also make associations. So we know that associations and memorizing information and performing very complex equations and processes, all of which computers can do, is separate from understanding. So I think from this we can infer that the interpreting and the obtaining of stimuli, which might include emotional stimuli, is outside of understanding, because it's not understanding the stimuli, it's just having it. Which means that there is something about the brain that computers can't do regarding these stimuli. And my proposal is that this is caused by three aspects of the brain that computers don't have, which would be computers have neurons, which I shall treat as kind of a fractal connections of the brain. Brains have that. Computers have microprocessors, which are very linear, very straight lines and right angles. Brains are made of carbon. Computers are made of silicon. And brains deal, I think, a lot more with electrical signals for thought than computers do, even though computers still use electrical signals. So my question is, if you made a computer out of carbon, if you made a computer that used fractal connections, or if you made a computer with a lot more electro signaling processes, do you think that these would be capable of understanding?
Are you asking what I think or what Searle would think?
Both.
Okay. Let me try to speak for Searle. He's going to ask you whether, in doing this building this new kind of computer, is the thing that allows it to do the sorts of things that humans do, walk around, respond to visual and auditory inputs in kind of interesting ways, is that a result of mere, transformation of symbols, ones and zeros? Or does it have something to do with the actual physical structures that the thing is built out of, right? So look, here's the extreme example. Instead of neurons built out of carbon, you build neuron-like devices out of silicon and wire that function just like a neuron, right? So they take electrical impulses, they produce electrical impulses in response. They're just built out of different stuff. And you build a brain out of them, right? Imagine studying an actual brain and putting one of these silicon-based neurons in every location if there was a carbon-based neuron in the actual brain. Okay, so let it start running. I think Searle would allow that thing has a mind. He thinks that computers are simulations of minds, but that there's a difference between simulating a mind and being a mind, just the way there's a difference between simulating a hurricane in a computer and actually being a hurricane. Hurricanes have causal powers. They can knock down houses that simulated Hurricanes don't. Now, a simulated hurricane can simulate knocking down houses, right? Because the computer program might say that, well, if the wind is strong, then this kind of structure will get knocked down. But yeah, Jacob.
So if you did that and you made one of those computer brains where every neuron is now made of silicon, and then you gave it a body with very similar functions as a human body but made out of different things, so you basically have human but steel.
Yeah. Have a man of steel.
Well then it can cause.
Yeah.
Right. It's not just a simulation. It can do what a human can do.
Right.
And then at what point is it not a human? I guess I don't.
Or,
yeah. Go ahead, Zach. Yeah.
Well, when you say human, a human is a Homo sapien. It's a very specific biological entity. It's evolved. It has a specific genetic code. What you're looking for, this robot with a computer that is actually a brain, it wouldn't be human, but it would arguably be a person, which is, I think, the question we're really focusing on.
Yeah, I'll change my wording there, make it person, and then, yeah.
And I would respond, I think it would be a person if it was sufficiently understanding to be considered one.
Yeah, so do I, and I think Searle could say the same thing. Yeah, go ahead, Alexandra.
Could you just relate it back to the idea that he had about the biological processes causing the mind exactly? Like, how does that relate to that exactly? Again.
How does it relate to this example of the artificial person?
No, like the discussion that was happening right now that Zach posed the question to. Because it felt like we were proving something different, but I thought we were trying to prove that the biological processes cause the mind.
Oh, no, I'm not quite sure how to prove that. The important thing about Searle's position is that he thinks that there is something about the physical structure of the brain that gives it powers, causal powers, that a mere computer that is something just running the appropriate program does not have. What is it about the brain? It's very unclear.
That's what I don't understand.
Yeah.
Why is it? What makes it different? If it's, I mean, yeah, it's physically different, but
yeah.
Why did the difference make the difference?
So, I think the idea is kind of like this. When you have a thought and you do something on the basis of that thought, Searle thinks that that thought is actually a state of the brain, right? Maybe it's a set of neurons firing in a certain way that has the power to cause the body to move in the appropriate way. The computer model says that what happens here is there are a bunch of symbols that get transformed according to these rules that go from, so maybe some string of those symbols is the thought that you're having according to the computer model, and it gets transformed into other symbols that then get sent down through the robot's hydraulic pumps or something like that, and causes it to move around in a certain way. Searle doesn't think that in that description there is a state with causal power the way there is in the brain when you have a thought about what to do. They're just symbols that are getting shuffled around. There's nothing there that he thinks can be called a particular state with particular causal powers. Does that help at all?
Yeah. Yes.
Yeah.
It does.
Yeah. That's about as, yeah.
Is Searle still alive?
Yeah, he is. Yep. My wife took classes from him at the University of California, Berkeley.
Maybe
Yeah,
we
no,
should
this
just ask
picture,
them.
that picture at the beginning of this. Oh, wait a minute. Let me go back to the slides here. That's Searle. That's a pretty recent picture. I've talked to Searle, actually. I went to a conference and talked to him for a minute. He's a very fun speaker. He stomps around and he gets very emphatic about things. And yeah, that's him on the top. That's a pretty recent picture. Now, let me just quickly mention this guy, Ned Block, who's there on the bottom, and his argument in this paper called Troubles for Functionalism, that also involves China in a different way and was published around the same time. Totally different reasons for the involvement of China. For Searle, it was because he just doesn't understand Chinese. For Block, it's because China at the time was the only country with 1 billion people in it. So here's Block's argument. This is called the China-headed system argument. Take a robot, like imagine a Bender, right, who has that radio transmitter coming out of the top of his head. Do you guys know who Bender is from Futurama? No? Okay. Anyway, don't worry about it. There's a robot. There's nothing inside the robot's head. Instead, what this robot does is it sends out radio signals to these satellites that are arrayed all above the population of China. Okay, and those satellites receive signals from the robot, and they can send signals back to the robot. Okay, now imagine everyone in China is given a little radio transmitter with a little LED display on it. And what happens is when the robot is in a certain state, it sends that signal to the satellites. The satellites show to each person in China what state the robot is in. Okay. Then each one of those people is told, when you're given a certain state number, right? Your state number is 35, your state number is 1,240, your state number is blah. When you see that state come up on your little transmitter, push a button. And when you push that button, it sends a signal up to the satellites, over to the robot, and the robot does something. Okay. Now, you remember how you can display a computer program as one of those big machine tables, right? Where there's a little rule in every square. Like if it's in state X and you have input Y, then produce output Z, right? Now just imagine that every one of those squares, a rule in each square is assigned to each person in China, right? So that each person in China, as it were, becomes one of the squares in that big machine table, the program for the robot. Okay. The idea here is that the country of China plus the system of satellites becomes the robot's brain, in effect. Whenever the robot receives a certain physical input, it sends it out to the population of China. The right people push their button, and the robot responds as a human would if functionalism is true about the mind, right? Because if functionalism is true, then there's got to be a big table with rules in every square. Just let the population of China be the realization of that table. Question: would that robot have a mind? Block says no. He says it's crazy to think that the robot would have especially a conscious mind because of this setup. So this is an absent qualia argument. So the claim is that the robot doesn't have a mind, it doesn't have any qualia, it doesn't have any conscious states. There's nothing it's like to be the robot. Therefore, functionalism, computer model included, can't be the right theory of mind. Another pretty interesting argument. Okay. Let you think about that.
I don't.
Oh, that was good. That was good, Jacob. Is there do you want to say something?
No, no, I don't want to say anything. Not yet.
Okay. Well, we're going to continue this kind of line of thinking with that argument that I just rehearsed. in the next paper. So Frank Jackson's paper, Epiphenomenal Qualia. You'll learn a little more about this word qualia if you don't already know it. I want you to focus on understanding the argument about Mary. First, he gives an argument about this guy Fred. Then he talks about Mary. Focus on the Mary argument. And then in Paul Churchland's response to Jackson, focus on understanding the first objection that Churchland gives to Jackson's argument. It's in the section called The First Shortcoming. You can read the second section of Churchland's article if you want to. I don't really plan on talking about that section, but by all means, you can ask questions about it. And so what I want you to do for your journal entry is first, do you think qualia exist? So Jackson talks about qualia. Do you believe in these things? Why or why not? And then briefly summarize the debate between Jackson and Churchland, and tell me who you think is winning and why. Okay. And then the standard couple of questions for discussion. Okay. All right, guys, that's it for today. Good job with that stuff. Keep thinking about it. And we'll continue talking about these arguments next time. All right, see you guys.
Bye. Bye.